Why is NASA, the world's premier space agency, throwing away the most advanced aerospace alloys ever created just to build satellites out of wood? It sounds completely insane. We are living in the age of reusable rockets, massive satellite constellations, and artificial intelligence. Yet the greatest minds in space exploration are stripping away the titanium and carbon fiber to copy a design from our ancestors. They aren't just experimenting, they are pivoting. Imagine a high-tech clean room at NASA, a place where you'd expect the smell of ozone and sterile metal, but instead, it smells like a high-end woodshop. This isn't a joke, and it's not a step backward. While the rest of the world is obsessed with building the most durable, indestructible machines possible, Japan and NASA have realized something terrifyingly simple. They've looked at the billion-dollar scrap heap floating above our heads and decided that the future of the cosmos isn't metal, it's organic. This cheap and primitive material is actually a stroke of absolute genius. It is a technology that doesn't just survive the vacuum of space, it thrives in it. By ditching the traditional high-tech playbook, they are about to solve a crisis that has been haunting the industry for decades. You see, when everyone else was focused on making things tougher, these engineers decided to make them smarter. They've cracked the code of orbital physics by looking at a tree, and what they found is about to change the rules of the entire space game forever. To put this in perspective, let's look at the cold, hard numbers. A typical communication or research satellite can cost anywhere from $50 million to over $250 million. The specialized aerospace-grade aluminum and titanium housing alone accounts for millions in raw material and precision manufacturing. Now, compare that to a precisely carved block of Magnolia wood. It costs almost nothing. But here's the position paradox that the industry didn't see coming. For decades, we believed that expensive meant better. We built satellites to be fortresses, wrapping them in layers of metal to protect the delicate electronics inside. But every time one of these million-dollar fortresses reaches the end of its life, it becomes a ticking time bomb. Currently, there are thousands of dead satellites orbiting the Earth, a massive high-speed graveyard of metal. When these metal giants finally lose their orbit and plunge back toward Earth, they don't just disappear. As they hit the atmosphere at 18,000 miles per hour, the extreme heat tears the aluminum apart, but instead of vaporizing into nothing, that metal transforms into toxic alumina, aluminum oxide particles. These microscopic killers don't just fall to the ground, they stay suspended in the upper atmosphere for decades, literally eating away at our ozone layer. We are protecting our technology, but in the process, we are poisoning our sky. The more advanced we become, the more damage we do. It is a catastrophic failure of design, but this is exactly where the genius of the wooden satellite comes in. NASA realized that the upgrade to wood isn't a regression, it's an evolutionary leap in logic. While an aluminum satellite creates a cloud of poison, a wooden satellite like the LignoSat does something beautiful. As it re-enters the atmosphere, the wood doesn't shatter into toxic dust, it burns. It turns back into simple CO2 and water vapor, leaving absolutely zero trace behind. No toxic chemicals, no debris, no floating graveyard. By choosing a primitive material, we are solving a trillion-dollar problem that the world's most expensive alloys only made worse. It's a shift from building machines that last forever to building machines that respect the environment they are protecting. We are finally learning that in the vacuum of space, the most modern solution isn't the one that costs the most. It's the one that leaves the smallest footprint. This isn't just about saving money on materials, it's about saving the very atmosphere we need to survive. And the way these engineers have managed to make a piece of timber survive the radiation of the sun is even more mind-blowing than the material itself. But how does a piece of wood actually survive in the most hostile environment known to man? To understand the genius of this, we have to peel back the layers and look at the molecular architecture of the Magnolia tree. On Earth, wood is vulnerable. It rots, it burns, and it decays. But the moment you launch it into the vacuum of space, the rules of physics are flipped on their head. You see, wood only rots because of bacteria and moisture. In the cold, dry vacuum of orbit, those biological threats simply don't exist. And fire, combustion requires oxygen. Without an atmosphere, a wooden satellite could sit directly in the sun's path for a century and never catch a single spark. In fact, when engineers cracked open the test samples after months of exposure on the International Space Station, they found something that shocked them. The wood didn't just survive, it became even more durable. In the absence of water, the organic fibers become tightly woven and fused, turning a simple block of Magnolia into a material that is as rigid and stable as some industrial polymers, but with a fraction of the weight. But here's the real technological twist, the aha moment that makes this more than just an environmental statement. To understand this, you have to understand the Faraday cage problem. Traditional metal satellites are essentially flying lead boxes. Because aluminum and titanium reflect electromagnetic waves, Engineers are forced to mount every single antenna, sensor, and transmitter on the outside of the hull. This creates a massive engineering headache. These external components are fragile. They have to be folded up during launch and then deployed in space using complex mechanical arms that often jam or fail. If the antenna doesn't unfold, your $100 million satellite is nothing more than a very expensive brick. But wood is different. Wood is electromagnetically transparent. It doesn't block radio waves. It lets them pass through like light through a window. This changes everything. By building the chassis out of wood, NASA can move all the sensitive communication equipment inside the satellite's body. The antennas are protected by the wooden hull itself, acting like an invisible shield. Think of it like the Lucas drone's internal backup system. Instead of relying on exposed, vulnerable parts, the wooden satellite houses its brain and ears deep within its own chassis. This eliminates the need for complex deployment mechanisms and drastically reduces the risk of mechanical failure. The signals simply pulse right through the grain of the wood, reaching the internal receivers with pinpoint clarity. And there's an even deeper level to this biological design. NASA engineers have begun to view the wood grain as a kind of biological nervous system. In a metal satellite, heat is a nightmare. Metal absorbs solar radiation and conducts it rapidly, creating extreme hotspots that can fry delicate microchips. You have to install heavy, expensive heat pipes and radiators just to keep the internal temperature stable. But wood is a natural insulator. It doesn't conduct heat, it manages it. The cellular structure of the Magnolia wood acts like a high-tech thermal buffer. When the sun hits one side of the satellite, the wooden hull absorbs the energy slowly, preventing a sudden thermal shock to the electronics inside. It's like a living skin that breathes with the temperature changes of the cosmos, while a metal frame would warp and expand, potentially cracking the precision lenses of a telescope or camera. The wooden fibers remain stable. They are fused in a way that allows them to shrug off a 300-degree temperature swing without a single microscopic fracture. This isn't just a box made of timber. It is a highly calibrated organic machine. It is a system where the material itself does the work of three different mechanical systems. It is the structural frame, the thermal insulator, and the antenna window all at once. By stripping away the complexity of modern alloys, these scientists have created something that is fundamentally more reliable because it is simpler. They've replaced 1,000 moving parts with a single, elegant piece of nature. It's the ultimate stealth technology, a satellite that is invisible to interference but perfectly tuned to the frequencies of Earth. We are looking at a future where our most advanced eyes in the sky are not cold, dead metal, but a warm, organic presence that feels more like a living thing than a machine. But as perfect as this wooden sentinel is in the silence of space, its most dramatic moment and its most terrifyingly beautiful performance only happens when its mission is over. When it's time to die, the wood doesn't just fail. It performs one final act of grace that puts every metal satellite in history to shame. Every mission, no matter how ambitious, ends in the exact same place, the death dive, a terminal, 18,000-mile-per-hour plunge into the Earth's atmosphere. And this is where the hidden, brutal reality of modern technology is finally exposed to the world. When a metal satellite reaches the end of its life, it doesn't just drift away, it becomes a high-speed metallic hazard. As gravity pulls it back into the thick, resistant layers of our atmosphere, raw physics takes over. Friction generates temperatures that instantly scream past 3,000 degrees Fahrenheit. For a traditional satellite made of aluminum or titanium, this is a moment of total violent destruction. The solid million-dollar structure shatters, the metal casing is literally ripped apart by the sheer supersonic pressure of the air. It doesn't just burn, it disintegrates into a supersonic spray of billions of microscopic fragments. But here's the terrifying part that most people never see. When aluminum burns at these extreme atmospheric temperatures, it undergoes a devastating chemical transformation. It turns into alumina, aluminum oxide. These particles are microscopic, razor-sharp, and incredibly stubborn. They don't fall to the ground. Instead, they stay suspended in the upper stratosphere for decades, acting like an invisible chemical parasite that slowly gnaws away at our ozone layer. We are essentially trading the convenience of 5G and global GPS for the long-term health of the planet's only life support system. Every metal satellite launch is a silent deposit into a poisoned sky. It is an environmental disaster unfolding in slow motion right above our heads, shielded from our view by the void of space. The sudden violent stop causes the metal to be torn to shreds, sending hundreds of lethal fragments flying outward before they melt into this invisible, permanent poison. This is the dark side of the space race, a legacy of metal that lasts for generations, creating a toxic dust barrier between humanity and the stars. Now, compare that to the wooden satellite. When the LignoSat enters that same death dive, the physics of the atmosphere are just as brutal, but the outcome is a masterpiece of natural engineering. The The wood doesn't shatter into lethal fragments or create a toxic cloud. It vaporizes. As the extreme heat slams into the organic fibers of the Magnolia wood, it triggers a clean, total combustion. The entire body of the satellite essentially turns into a gentle, harmless mix of water vapor and CO2. It is a peaceful, almost invisible return to the Earth. There are no metallic sparks, no razor-sharp debris, and zero long-term chemical footprint left behind. In a fraction of a blink, the satellite is gone, leaving the upper atmosphere exactly as it found it. The contrast is jarring. On one side, you have immortal metallic poison that lasts for generations. On the other, you have the finite grace of wood that disappears without a trace. This tension isn't just about waste management. It's about the survival of the very atmosphere that protects us. We are finally realizing that the most advanced solution isn't the one that lasts forever, but the one that knows how to end with dignity. The raw physics take over, crushing the wooden structure until it is nothing but a wisp of gas, leaving the internal electronics to be incinerated completely before they ever touch the ground. The wood acts as a sacrificial shield, absorbing the total kinetic energy and converting it into simple elemental heat, shielding the environment from the toxic components that often leak from metallic wreckage. It is the ultimate act of engineering, a machine designed to destroy itself for the greater good of the biosphere. This isn't just a theory or a science project, it's Project LignoSat, a bold collaboration between Kyoto University and NASA. And the choice of material wasn't random. After years of testing different species on the International Space Station, exposing them to the harsh, raw atomic oxygen and intense cosmic radiation, researchers found a winner: Magnolia. Why Magnolia? Because it's a biological champion. It possesses a dense, uniform cellular structure that allows it to survive the violent, bone-crushing G-forces of a rocket launch while remaining incredibly stable against the extreme radiation and 300-degree temperature swings of deep space. This is a material that has survived on Earth for millions of years, and now it's proving to be the ultimate cosmic solution. In many ways, we are just coming full circle. Think about the legendary Spruce Goose, the massive wooden aircraft built by Howard Hughes. History shows that when we reach the absolute limits of what metal and synthetic alloys can achieve, we often return to the fundamental wisdom of the natural world. We are rediscovering that the core values of engineering, simplicity, efficiency, and sustainability are best embodied by the materials that grow from the Earth. The selection process at Kyoto University went through the most rigorous tests imaginable, proving that wood doesn't rot, warp, or crack in a vacuum. It actually becomes more durable as every trace of moisture is removed. Of course, we have to be realistic. Wood won't replace the heavy structural steel and advanced composites needed for massive space stations or future moon bases. It has its limitations. But, as a frontline defense for the thousands of small satellites that will soon fill our orbit, it is the undisputed champion. It is a shield for both the technology and the planet. The age of orbital graveyards is finally coming to an end. We are proving that our eyes in the sky don't have to leave a permanent scar on the universe. We are moving toward a future where the machines we send to the stars can leave as quietly and cleanly as they arrived. We are a small team of 3 people dedicated to decoding the world's most complex engineering mysteries from scratch. If you want to follow us on this journey as we explore more analytic animations, hit follow. The next chapter of space exploration isn't being written in metal, it's being carved in wood.